Hello. I'd like to start this presentation with a quick demo of my project. What I created was Project Hearth, the home environment automation for renters slash tenants hub. This is the central unit right here. This connects wirelessly to the two other modules, which control the lights for my kitchen and my bedroom. You probably can't see it very well here, but these two LEDs indicate that the hub is ready to communicate to the two modules, and the two modules also have LEDs that indicate that they are ready to talk to the hub. And then on these OLEDs, they say kitchen off and bedroom off for the lights that are in my kitchen and my bedroom. Now, if I press these buttons, they will control the lights there. So if I press the one for the kitchen, turns that on over there, which I'm recording that on my phone from the kitchen. And then if I press this button here, turns on the lights in my bedroom. And now I'll show you a close up of the modules themselves. First, we'll take a look at the kitchen module. This is connected to the light switch here that turns on and off the lights down around the corner there. And this LED here indicates that it is ready to talk to the hub itself. Now, whenever I press the button on the main hub, it sends a signal to the kitchen module to flick the switch, turning the lights off downstairs. Next is the module in my bedroom, which is very similar to the one for my kitchen. Once again, has the LED to show that it's ready to talk to the hub. And when you press the button on the hub, it moves the servo, turning the lights off, and vice versa. Now let's take a look at how it works. So here's the system overview. As you can see, we have the main home hub, which communicates to the two different light modules via a communication protocol called ESP-NOW, which is specific to ESP32 microcontrollers. And then those modules will then turn the light switches on or off using the servos and their physical integration. Taking a look at the hardware, I designed PCBs to mount the ESP32 microcontrollers to, as well as add JSD connectors for all of the I/O. Doing so enabled me to be able to quickly swap out different components to test different options. As you can see here, we have the two main PCB designs that I used in this design, with the one on the left being for the hub with all sorts of extra outputs possible. I left extra outputs and inputs for the sake of potential expandability. And then the board in the middle is the one for the light switch modules, which has less I/O because it doesn't need as much. But you can see it also has the 3-pin connector for the servo there. Then you can see up in the right, that's kind of one of the connectors that I did was the 4-pin for the different displays, which are communicated with over I2C. So they have the 4 pins with the positive, negative, SCL, and SDA. And as you can see by those couple sketches there, I tried to be consistent with the pinning of the connectors. Taking a look at the enclosure design, this is all modeled in Fusion 360. They're fairly straightforward boxes for the most part, with some mounting for the PCBs, as well as the different buttons, LEDs, OLED displays, servos, all of that stuff. The most complicated bit of this was the design for the linkage to actually move the light switch itself. I went through a few different variations of this before settling on the 3-part system that I have there. This was probably the one of the more complicated bits, or easily the most complicated bit of the enclosure design. Now let's look at the software design of the hub. So just the general flow chart that it goes through is it initializes everything with all the inputs, outputs, the OLED displays, and then it sets up ESP Now by creating peer devices with the two different modules using via their MAC addresses. Then it goes into the continuous loop where it checks for a button press. If there is a button press, then it sends a message to the modules to change the state. Then it updates the displays, loops back around, checks again for the button press, so on and so forth. Some specific libraries that I needed for this were your Wi-Fi library and ESP Now libraries to do the ESP Now communication, as well as the Adafruit SSD 1306 and the GFX for setting up the OLED displays over I2C. And then for the modules, it's a little simpler. You have a lot of the same initializations, adding the ESP Now peer, which the modules only needed to be peer devices with the hub, so that was a little simpler. Then they go into the loop where they check for the message from the hub. If they get a message, then the servo changes the state, hitting the light switch, then it loops back up to check for more messages. Again, libraries, the Wi-Fi and the ESP Now for the ESP Now communication, as well as the ESP32 servo library to control the servo. In terms of unfinished software, software is where I have the least experience. So there are certain things that I didn't quite get to that I was very far along on, but just wasn't quite buttoned up enough to fully share in this project. So hosted on DigitalOcean, I have an Mosquito MQTT broker within a Linux server that will eventually be able to talk to both the hub here using some Arduino MQTT libraries, and then also communicate to a web app, which I've built in HTML, CSS, and JavaScript, which utilizes the Payho MQTT client. The reason I wanted to create this app was so that you could control the lights from anywhere in the world as long as you have an internet connection, which would be really useful for whenever you're coming home and it's late and you can't see anything. Or if you just forget to turn the lights off. In terms of future improvements, I would really like to add controls for the living room lamp, as that's the main light whenever you enter the home, and when it's dark out, you trip over stuff. I'd also like to try to add some temperature control for my window AC unit. I need to be able to account for multiple switches that turn on the kitchen lights, because there are 2 switches in 2 different places that toggle the lights in the kitchen. And then the last thing is I would like to be able to tell when a light switch is manually switched. So this will likely involve adding some sort of mechanical switching action that's paired with the servo motion to create a digital input to the modules, which that can then be relayed back to the hub. As the enclosure design was intended so that people could still manually switch the lights. That's my design project 3. I hope you liked it. And yeah, thank you for a great semester.